Hey, what's up everybody? Got a quick video for you today on finding vectors, components of vectors, and then working with those vector components. So let's go ahead and dive right in. What we talked about today is finding magnitude and direction of a resultant vector. And if you remember, if we're looking for information about a resultant vector, and remember that resultant vector is the vector that is being applied at some angle. All right, so if I take this one right here, I'm going to stretch this guy out a little bit like this. Then I would have components of this vector. That would be something like, draw it out here. We'd have our x component right here. Then we would have our y component perpendicular to that, right there. We've got a 90-degree angle in between these two, and some angle theta. Now remember, we want that angle to be located at that location because it is in reference to the x-axis. And that x-axis is right here, our x component and our y component. All right. So let's talk about how we can find this resultant vector and angle. So let's say that I tell you that the x component is equal to 7 and the y component is equal to 10. All right. Now with this information, make this all a little bit smaller here. We have two things that we need to do with this information. First, I need to find the resultant. And if you remember, the resultant magnitude can be found using Pythagorean's theorem. Pythagorean's theorem says a squared plus b squared equals c squared. We're going to change that to x squared plus y squared is equal to r squared, where r represents the resultant vector. So then I can just find r by taking the square root of both sides. And when I do this, I get 7 squared plus 10 squared, which I have not done yet, so give me just one sec. 49 plus 100, square root of 149. It's going to be 12.2. All right. Now to find the direction, we use trig. Specifically, we're going to use tangent. Tangent of theta is equal to opposite over adjacent, which for us, opposite represents the y component because it is opposite our angle. Adjacent represents the x component. Now to undo tangent, we need to take the arctangent. So this becomes theta is equal to the arctangent of 10 over 7, which gives me I'm going to come back to that one. I'm not going to be able to do that on my calculator real quick. But that'll give us some angle. It's probably going to be a little greater than 45 degrees. And so then we would have our magnitude and the direction of the resultant vector. Moving on, let's talk about finding components. All right. So this is like if I gave you the resultant and the angle, and I asked you to find the components that make that up. So let's say that I said, here's my resultant, and this thing is going to be equal to 10 meters. And I want to know, what is the x component of this? And what is the y component of this? Mistake there. Maybe I can grab it. Maybe not. Never mind. Oh boy. Okay. So, finding, and let's say that this angle is 30 degrees. All right. So we know that our resultant displacement is 10 meters. We know that theta is 30 degrees. And I would like to know, what is my x component of my vector and what is my y component of my vector? What are these? So now we need to go to our trig function. Some old hippie came a-hopping through our apartment. So, some old hippie came a-hopping through our apartment. And these are going to be the functions that I use to find these two components. So let's think about sine. Sine is the opposite over the hypotenuse. Now for us, opposite gives us the y-coordinate, adjacent gives us the x-coordinate, and hypotenuse gives us the resultant vector. So if I want to find the x component, I'm going to use anything that involves the adjacent, which for us is going to be either cosine or tangent. Now because I know what the hypotenuse is, cosine makes the most sense here. So to find the x component, I'm going to go cosine of theta is equal to the adjacent x over the resultant r. So cosine of theta is equal to x, and I multiply by r. So this becomes 10 times the cosine of 30 is equal to x. I'm just going to leave that as that for now. To find the y component, take the same approach. Here, though, I'm looking for what is this right here. The y component, remember, refers to the opposite. So I can use either sine or tangent. I'm going to use sine here. Sine of theta is equal to the y component over the resultant, which means r times the sine of theta is equal to the y component, which gives us 10 times the sine of 30. You can calculate that out, get your y and your x component. That very simply is how we find these pieces given a resultant or given an angle. You can do the same thing if you're given other pieces to the puzzle. So let's say that a problem says a ball is launched at an angle of 20 degrees and it has an initial horizontal velocity of 8 meters per second. All right, so a ball is launched at an angle of 20 degrees and it has an initial horizontal velocity of 8 meters per second. So let's draw that out. Here's my horizontal velocity. Here's my vertical velocity, and we know that this is 8 meters per second. And what I want to know is what is the total velocity? What is the resultant velocity here? So let's think. I know velocity in the x is equal to 8 meters per second. I know that theta is equal to 20 degrees. And what I want to know is what is my total velocity? So again, let's think about our trig functions. Sine, which is opposite, over hypotenuse, which is y over, I'm actually going to write all these out. Sine of theta is y, velocity in the y, over the total velocity. Cosine of theta is velocity in the x over the total velocity. And tangent is velocity in the y over velocity in the x. So if we think about what we know here, we know velocity in the x, we know theta, we want to know v. Cosine makes the most sense here. So I say cosine of theta is equal to velocity in the x divided by velocity. Now, what I can do here is I want to rearrange for v. So what I do is I get v times the cosine of theta is equal to velocity in the x. Then I divide by cosine of theta to get v is equal to velocity in the x divided by cosine of theta. Now I can just plug in. Say v is equal to 8 divided by the cosine of 20. And we would plug that into our calculator, get an answer. So you can see that it's pretty straightforward to just solve for these when we have all of this information given to us. What we just need to get used to is working with these trig components here. All right? So that's a quick video about how to work with vector components. You're just going to be applying those basic steps. What you guys need to be doing is first draw a picture. 2, identify knowns and unknowns. 3, solve. Your main things you're going to use here are x squared plus y squared is equal to r squared, and then sine of theta is equal to y over r, cosine of theta is equal to x over r, and tangent of theta is equal to y over x. All of these problems are going to boil down to some variation of those. All right, guys, let me know if you have any questions, and good luck on the problem sets.